Welcome to VidyaNest. And last day, we terminated the indefinite integral with uh, shortcut tricks, and today we'll extend our knowledge to the field of definite integral. Definite integral, you can expect 2-3 sums in board, as well as it encroaches importance even in JEE level, JEE main and advanced. Definite integral. Definite integral means, actually integration means what? Integration means its symbol. You see, its symbol is S. S stands for summation. Summation. But in indefinite integral, that much of use of that summation we haven't got. Now in definite integral, we can work on it. Suppose there is a plane x and y axis, and there is a curve y is equal to fx. We will find the area possessed by this curve with this horizontal x-axis. Okay, this is the junction of x and y. From this point drop a perpendicular, from this point drop a perpendicular. Now I have to find the area within some interval. I am letting this thing as x is equal to a, this thing as x is equal to b. Then this area will be split into equal interval. Let us split it into equal interval. See, this part, the widerness from A to B is split into n equal sub-intervals with h. Now there are n number of n sub-intervals. So one interval has width h. So n interval will have nh. Suppose this is h. Total n number, n repeats h times. So this length is a, this length is b. So remaining part b minus a. NH is b minus a. Now you, from each corner, you drop perpendicular to the next vertical line. That means this total area is split into some rectangles. This is x is equal to a. This curve is y is equal to fx. So this part is fa and this part is h. So what is the what is the area of this part? First rectangle. Area of the first rectangle is length into breadth. Breadth is h, length is fa. fa into h. Okay. What is the, see, this is h. So, this part is a plus h, x is equal to. Once x is equal to a plus h, then what will be the height? A plus h. And then I will find the area of this rectangle. Okay. This rectangle's area. Plus, go to the next rectangle. See, this part is h plus h. So, this is total a plus 2h. Once you get a plus 2h, this will be what? Length a plus 2h. A plus 2h. And a plus 2h into h. And the, process is on, and it will last. If dotted line, if last term will be n minus h into h. So, in finding the area possessed by the curve, we have got the summation of rectangles. Okay, how many rectangles are there? N number of rectangles. Each rectangle's width is. So, this is the area, but does it possess the whole area? No. You see, this part, very negligible, but that is still uncovered. This part is uncovered. This part is uncovered. So, how to cover that uncovered part? See, if I, pull the rectangle up to cover this, pull the rectangle up, then obviously the width will be lesser. And lesser up to what extent? Tends to 0. So, once you get the term tends to 0, that means somehow it is related to limit. So, to cover the uncovered part, I have to take limit in the expression. Once you got the limit, that means the whole area possessed by the curve with x-axis is considered. That is nothing but a to b fx dx. So, by definition or by perception, we have got what is actually definite integral means. A to b fx dx is equal to the sum of the rectangles, sum of the area of the rectangles with the introduction of limit h tends to 0. So, that is the definition of integration, but that is not the working rule. That is not the working rule. How to frame the working rule from this definition of integration? See, instead of writing all this plus sign, we can introduce a term that is called summation, sigma. Okay, so I can write this integration a to b fx dx is equal to limit h tends to 0. Instead of writing all this thing, I can write one thing. I can take h common. And keep it outside. What will be left in the bracket? fa f a plus h f a plus 2h dot 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 f a plus n minus 1 into a. Okay. Now, instead of writing this, it will be better if you use summation sign. Sigma f a plus rh, where r starts from 1, 0 and ends with n minus 1. Ends with n minus 1. So that is called definition of definite integral, but still we have to simplify it more. How? You just see. Just now we have got a to b fx dx limit h tends to 0, h summation r 0 to n minus 1 f a plus rh, which we have just used here. But the problem is that if you keep r 0 to n minus 1, then in calculation we might have faced some difficulties. So our aim will be to get the summation from 1 to n, not 0 to n minus 1. Okay. How to make it 1 to n? See, you rewrite the summation. First you put 0, f a plus h, f a plus 2h, f a plus n minus 1 into h. Now, to make it from r to 1 to n, you have to do one thing. Limit h tends to 0. You just borrow one thing, just a plus h, a plus 2h, a plus n minus 1 into h. So we could reach up to this stage in the previous line. So what new we have to introduce? You add one term extra, a plus nh. That term is extra. You introduce that, and you have to subtract for balance. Now, what privilege we got from here? We have got the continuation from, you see, R1 to N. Then you can ask me what I will do with this first term and the last term. That has become burden. No, we will club them together. See, H, you club these two parts in a bracket. And other part will remain unaltered. So you do one thing, you keep keep these two separate. Okay, yeah, I will keep this part separate and that part, later part separate. See, split into two limit. Okay. So here, if I put h tends to 0, means though h is not equal to 0, but for sake of calculation, we will put 0 and I will get the defined value. So no harm in putting h is equal to 0 here, and that part will be nullified and turned into 0. And instead of this part, for which we are running after, see, limit h tends to 0, instead of writing all this plus sign, you put sigma a plus rh. Now we are able to get the summation not from 0 to n minus 1, but from 1 to n, where nh is equal to b minus a. So that is the formation of the definition of integral. So we have got a to b fx dx is equal to limit h tends to 0 h summation of a plus rh, where r 1 to n, where nh is equal to b minus a. nh is equal to b minus a. Now it is called definition of definite integral, or integration is expressed as a limit of a sum. Okay, thus we can express definite integral as a limit of a sum. Hope you could catch. Now let us do one sum involving this. Okay. See, 0 to 1 e to the power x dx. Evaluate. Suppose the question is given in this way. Evaluate by limit of a sum, or by definition of integral, definite integral. Okay, how to pursue this sum? See, once you get this type of sum, first you recall the formula. Formula, as a side note, you write a to b fx dx. Here, instead of a to b, what is given? 0 to 1. So here a will be considered as 0 and b will be considered as 1. Then it is equal to what? Limit h tends to 0 f a plus rh, where r starts from 1, ends with n, where nh b minus a. So here nh b minus a, 1 minus 0, that is 1. Okay. Now a is 0. That means that if a, once you get this a is 0, it will be turned into only f rh. So you do one thing. First you compare to fx. Here fx is e to the power x. Okay, fx is e to the power x. Now we have to find f a plus rh. F a plus rh is nothing but a to the power e to the power a plus rh. What is a? A we got 0. 0 plus rh. E to the power 0 plus rh. That means f rh is nothing but e to the power rh. So directly now from this step I can put the result, that result which is derived in the formula. What is the formula? You see here, I can write limit h tends to 0, limit h tends to 0, see h summation f rh. R starts with 1, ends with n. Limit h tends to 0, h. What is f rh? E to the power rh. E to the power rh, where r starts from 1, ends with n. Now, keep on putting the value of r from 1 to n. How? See, limit h tends to 0, h, put 1, e to the power h, 2, e to the power 2h, 3, e to the power 3h, e to the power nh. So, does it remind you anything? Yes, it reminds you a series. See, the power is increasing. That means series implies a GP series, geometrical progression. How? You see, limit h tends to 0, h, e to the power h, e to the power h whole square, e to the power h whole cube, e to the power h whole to the power n. So it reminds you which formula? I am just reminding you ar square, ar to the power n minus 1 by r minus 1. So here first term will be, so there must be a demarcation line, otherwise the sum becomes so clumsy. See, limit h tends to 0, h, a, first term, what is the formula? First term a, then r to the power n, common ratio, second by first, by e to the power h. E to the power h is r, r to the power n minus 1 by r minus 1. So, how does it help us? What I will do with this h? By division lemma, that h will go to the denominator of this. E to the power h, instead this will become e to the power nh minus 1. That part will give you what? That part will give you 1. That part will give you 1. And only this part will remain. And nh is what? nh few minutes back you got 1. So put all this. And h tends to 0. Put 0. That will not give you any undefined value. So this is 1. This is 1. E to the power 0. E minus 1. And in denominator 1. Answer is e minus 1. This is called definition, the definite integral evaluated by limit of a sum or definition of definite integral. Hope you can understand. Now let us skip to the new property of definite integral. Okay. So I hope you have understood this depiction. So let us skip to the next topic. Fundamental theorem of definite integral. Fundamental theorem of definite integral. What is that fundamental theorem? And it is very known to you, very much known to you. A to b fx dx. After integration, you will get a different function, say phi x. Now put upper limit minus lower limit. Okay, and it is very known property. Even in physics or chemistry or any other anywhere, you have had the practice of this. Like 0, 1, 2 to 3 square dx. Okay, so complete the calculation. 19 by 3. Now, in this regard, we will discuss about the shift of origin. What is that? Suppose you have got the integration of this type. You can tell me, we got this integration as a formula. We use this as a formula in definite integral. But here, my motto is to make you understand how to change the lower and upper limit. How to change the lower and upper limit, that is called shift of origin. Now, you just, from your knowledge of indefinite integral, you can say what substitution is required here. X is equal to a sine theta. Once you take it as x is equal to a sine theta, that means you are converting from x-axis to new axis theta. Means the integration, the line integration with respect to which you are integrating, but at the beginning with respect to x. Now it is being shifted to with theta, d theta. So you have to differentiate. You are all aware of this. So dx a cos theta d theta. ओके, ठीक है. तो ये जो dx जो पार्ट है, ये कन्वर्शन हो गया किस में, न्यू एक्सिस थीटा. बट दैट लिमिट was given with respect to the old axis, and you are shifting from old axis to new axis. That means this limit has to be changed. Okay, this limit has to be changed. How to change the limit? The solution table you draw. X and theta. See, what is the upper limit? A. So you put A. If I put x is equal to A, I will get theta pi by 2. If I put x is equal to 0, I will get theta 0. So the you see, the limit is shifted to new limit with respect to new axis. A has become pi by 2. So instead of A, you write pi by 2. Instead of 0, you write 0. Instead of dx, a cos theta d theta root over of, instead of x, okay. So a cos theta d theta, a square minus a sin theta whole square. So I am shifting from this place to this place. Main part is over. Now simplification is left. A cos theta. And from here you take a square common. See, this 2 is the power of this a also. What will be left in the bracket? What I will do, this a square. A square will be brought out of the limit. In terms of a, 1 minus sin square theta is cos square theta. Cancel. Okay, so that is the answer. This is the, mechanism of shifting the limit from one axis to other axis. That is called shifting of origin, and that is one of the important part of the integral. Okay, if you can't know this mechanism, then you have to solve definite integral by indefinite form. Means after solving by indefinite form, at the end you have to put the upper and lower limit. But here, once you know the shifting of origin, that means you need after integration, the substituted value which we have assumed will never be resubstituted. Okay, hope you understood. Now we have to go through few property based on definite integral. One of the most important property, first real numbering. Say first property is a to b fx dx. You can split it into two parts. Properties of definite integral. A to b fx dx, a to c fx dx plus c to b fx dx. Means, suppose you are finding the area between a to b, in the interval a to b. Now from a you are finding the summation of the area, and if you get it is the widerness is so big, then you can take rest. Suppose at the in an intermediate point you are taking rest, means the whole journey is broken into two parts, a to c, c to b. You can ask me that, okay, that journey could have been broken into more parts. Obviously, see, a to c, c to b. That means the whole widerness of the definite integral is split into two parts, a to b and b to c, c to b. Okay, you can split, you can bring more intermediate points between c and b and a and c. Now you can ask me, when we can use that? What is the use of this? Example. Use of this. See, you have got integration like this. Minus 1 to 1 mod x dx. Okay. Here you need to learn the concept of mod. What is the concept of mod? Mod x will be x if x greater than 0, minus x if x less than 0. That means 0 is that intermediate point whose right hand side gives mod x's positive value, left hand side negative value. So between minus 1 to 1, I can consider 0 as the intermediate point. So I can split these into two parts, minus 1 to 0 and 0 to 1. Minus 1 to 0, that means x less than 0, mod x will be minus. And 0 to 1, where x greater than 0, mod x will remain as plus x. What we will do with this minus brought out, and x's integration is x square by 2. Here, now put the upper limit. Minus lower limit. Upper limit, lower limit. Minus minus plus, minus 1 whole square 1. Answer is 1. So that is the use of the first formula. Hope you understood. Next one, property number 2. Property number 2, a to b fx dx. Suppose you are finding the area from A to B, but if you change the order, means the direction, B to A, then there will be a minus sign. Okay, you can ask me then, if I exchange the direction, minus sign means area is vector. No, once you get the area, means amount, it is scalar, but the process by which you are finding the area, that is a vector. A to B, B to A, they are opposite in direction. So if I exchange the limit, there will be a minus sign. Okay, there will be a minus sign. For example, say 2 to 3 x square dx. In next line I can write 3 to 2, and once you have written, it will become a minus. Okay. Property number 3, in between same interval, you can change the variable with respect to which you are going to integrate the integrand. Okay. That means suppose there is a room. The room is bounded between these two intervals A and B, right, between these two walls. Now suppose in this boundary, you can change the color of the wall. Today white color, next day violet, next day red. So color is being changed, but the thing that the object remains same. Object remains same, only color will be changed. So the variable, you can see, you are as a person, You are changing your shirt every day. Okay, but the person remains same. That is oneness. Fx, I can write a to b fx dx, a to b f theta d theta, a to b fz dz. So that means in that interval, I can rewrite the integrand, changing the variable. Okay. Now, one of the most important property and one of the most useful property, let's give it 3 star, that 0 to a if a minus x dx is equal to 0 to a fx dx. One of the most important property. And this property I am showing how to establish. Okay. See, 0 to a if a minus x dx. What is the basic sense of integration? When we will be allowed to integrate one integrand if the variable is same. But here you see variable is x, but here a minus x. We have to make them same variable. So I will let is equal to z. Once you consider a minus x as z, then you have to differentiate this with respect to x or z to convert dx to dz. So that conception you have already consumed. That give you, this part will give you 0. So dx minus dz. So dx has become minus dz. Now in place of this dx, I can put minus dz. And once you substitute it, a minus x by z axis, then you need to replace the lower and upper limit. How? That I have already explained you. Draw the solution table. Put the upper limit. In place of x, you put a. A minus a, how much? Z0. 0, a. So this integral becomes what? When x is a, then z is 0. When x is 0, then z is a. A minus x is fz dx minus dz. Hope you understood. Now, what I will do with this minus sign? Minus will be brought out. Now, how to remove this minus? You got this formula, formula number 2. If you exchange the limit, there will be a minus sign. So, if I exchange this limit with each other, minus will become plus. Now, in property number 3, we have got between same limit, we can rewrite the integrand by changing the variable. So, fx dx. So, that is the establishment of this formula. 0 to a f a minus x dx is equal to 0 to a fx dx. Now, the question is, what to use, which formula? Example, suppose you have got 0 to pi by 2 sine square theta d theta. Okay, had it been given in indefinite integral, you would have done in what way? You would have multiplied this thing by 2 and divide by 2 and used that multiple angles property. But once you know this formula, then your job will be much more simpler. Now you can ask me how to understand where to use this formula. See, once you get that trigonometrical function like sine or its complement cos, a minus x, 1 minus x, okay, then you have to use this, see, a x, a minus x, 1 minus x, fx, like that, cos theta, cos 90 minus theta, sin theta. So mainly in trigonometry complementary function we will use that. See, sin square theta d theta, sin theta's complement is what? Cos theta, and that is f theta. F theta is sin square theta. It depicts what? X is replaced by what? A minus x. Here theta will be replaced by what? Instead of theta, what can I write? A minus x. Pi by 2 minus theta. Now, sin square pi by 2 minus theta. Cos square theta. So that is I, that is also I. So if I add I plus I is what? Sin square theta, this integrand and that integrand will be added. This is 1. 1's integration is theta. So 2i is equal to pi by 2 I pi by 2. Okay. So that is the use of this formula. One of the most important formula I have told. Now, another example, say integration of 0 to 1 into x dx. How to integrate that? Had you been in the arena of indefinite integral, you would have expanded with binomial expansion. But here, you have come to know the definite integrals property. And here you see the trend, x a minus x. So here you write the formula 0 to fx dx, 0 to a minus x dx. If I put myself in your position, I would have compared this sum to this formula in this way. We have x a minus x. So x a minus x, both are present. So somehow this sum is related to this formula. Let us take as this is as I and use this formula, means all x will be replaced by a minus x. 0, 1, in place of x you write 1 minus x. In place of x you write 1 minus x. So what changes will occur? Remove the bracket. Okay. Open it. split into two parts. This will give us so in place of x you put 1 and 0, 0 will give you 0. Here you put 1, n plus 1 plus 1, n plus 2. So that is the answer. Okay, that is one of the important sum for board level. Okay. Next property. Property number 5. Property number 5 depicts what? A to B fx dx. A to B a plus b minus x. Example, say 2 to 3 Now, if you get this sum, how will you catch this? See, there is a term x, 5 minus x, a plus b minus x. See, x, a plus b is 5, 5 minus x. So, somehow you are finding a relation between this sum to this formula. Okay. So, let us take this thing as I. Instead of x, you write all x is replaced by that. Five minus x, remove the bracket, only x. So write in order. I. So this is also I, this is also I. Just add them up. Denominator is same for both. Get cancelled. X 3 minus 2 1. Therefore, I is equal to half. So that is one of the use of this formula. Now, property number 6. Minus a to plus a fx dx means you are finding the area between plus a to minus a. If the the region is symmetrical with x-axis, that means no point of finding from minus a to plus a. Why? As they are symmetrical, you find this area and multiply by 2. So this formula can be written as 0 to a twice fx dx. What is called symmetrical form? Symmetric means Symmetry means line of symmetry. That is even function if f of minus x is equal to fx, and it will be 0 if f of odd function f of minus x minus 1. Okay, f of minus x minus 1. Now, example, say the sum is minus pi by 2, 2 plus pi by 2 sine cube x. If you get this sum, then your general perception is use sine 3 theta's formula, means 3 sine cube x is equal to 4 sine cube x is equal to sine 3x minus 3 sine x. But once you come to know this formula, then the sum can be terminated in 1 minute. See, here the integrand is fx sine cube x, put minus x. What I will do with this minus? It will be brought out minus fx. So it is odd function. Once you get odd function, don't proceed even. Just put 0. It satisfies this condition. Okay? It is 0. Okay? So that is the property number 6. What is property number 7? See. Property number 7. 0 to nt, n will be brought out if a x plus t is equal to fx. That is, fx is periodic function with period t. Okay, fx is periodic function with period t. In JEE, this formula will have, big impression. Example, say you have got 0 to 100 e to the power x by e to the power box x dx, where box x means greatest integer function. Now, 0 to 100, how to simplify it? Then you have to take the help of the concept of periodic function. You see, here x same power different x minus box x. You consider this thing as integrand. Let fx is equal to x minus box x. Now let us examine its periodicity. It starts with the natural number 1. See, you know the property of box function, box x plus n, if n is integer, so that one will be brought out. Cancel fx only. So it satisfies the condition of a periodic function. Therefore, f periodic function. So, and 1 is the period. It is the periodic function with period 1. So 1 will be left as upper limit, and according to this formula, that 100 will be brought out. Now, once x lies between 0 to 1, box x will be what? 0. Put here. What is the integration of e to the power x? E to the power x only. That is the answer. That is the use of this periodic function property in FE integral. Okay? Hope you understood. Now, we could reach up to property number 7. Now, property number 8. One of the most important property, like previous. See, 0 to 2a fx dx, 2 will be brought out if 2a minus x is fx, and it will be 0 if 2a minus x is minus fx. Example, see, suppose you have got one integral like this, 0 to pi sin x, x sin x, 1 plus cos square x. So, how to defend this sum? What formula will haunt you? In this sum, barring this formula, property number 4 also to be recalled to avoid the by parts. See, I am letting this thing I. Now, how to avoid this by parts? Why by parts is required? Here one algebraic function is given and trigonometric function is also given. So, how to avoid this by parts? Because if I use by parts here, the sum becomes clumsy and very much complex, and it become out of our grip. So, to ease the calculation, we have to avoid by parts using this property, which is just depicted. Zero to a fx dx is equal to 0 to a if a minus x dx. Okay. See, first of all, I will use this property number 4. All x in this integrand will be replaced by a minus x. What is a? Here a is pi and this is 0. 0 to pi minus x sin pi minus x 1 plus cos square pi minus x dx. Now it does what? Sin 180 minus theta. See, it will be equal to I. Sin 180 minus x, sin x, 1 plus cos 180 minus x minus cos x but its whole square will absorb the minus sign. Will absorb the minus sign. Whole square. So you could reach up to this stage. Now you can split the integrand with this minus sign. How? 0 to pi. Pi into sin x by this. Minus x into sin x by this. Now this thing is equal to I, because we had pursued from this level. That at the beginning, I assume this thing as I. So instead of this, I replace that I. Minus I. That minus I will be dragged in the left hand side. It will become 2I. And this pi is constant. It will be brought out. Now, maximum student will consider cos x is equal to z and substitute. But before doing that, we have one thing left. What is that? See, now use of this property number 8. In property number, but who will prompt you in exam, or as a beginner, how to start this? How to comprehend that I have to use this property? See, there is no hard and fast rule, but I am just telling you one trick by which you can comprehend that why in the, after this stage this formula is indispensable. See, here upper limit is pi, and we know sine, cos and other trigonometric ratios are positive in first quadrant only, all positive. So if I reduce the upper integral to 2 its half, means first quadrant, then it will be privileged for us to avoid the negative sign. See how to reduce the upper limit from pi to pi by 2. I am letting pi is equal to 2a. What is fx? Right aside 1 plus cos square x. So pi f2a minus x will be sin 2a minus x, 1 plus cos square 2a minus x. What is 2a? 2a is pi. Sin pi minus x is sin x, and that is 1 plus cos square x. So we get back fx. So what formula? What formula does it relate? This thing relate this formula. So the upper limit will be reduced by 2, and that 2, and according to the requirement, that 2 will be brought out. Two to cancel. Now see, after this stage we can write here I is equal to, now the limit is reduced 2 pi by 2 from pi. Let cos x is equal to z is equal to dz put upper limit cos pi by 2 0, put 0 1, so it is turned into 1 to 0, minus will be brought out dz by 1 plus z square. If you wish, you can remove this minus sign by extending the limit. So that is tan inverse z, put upper and lower limit. Now the fundamental property, tan inverse 1 is nothing but pi by 4 and that is 0. That is the answer. Okay. So if hope you understood this depiction and what to use this formula. Okay. And this sum is important for board and JEE both. Understand? Now, property number 9, and that would be the last property for the day. Okay, important property that is. Property number 9, strictly for JEE. Strictly for JEE. See, suppose property number 9 for JEE only. You can't use this thing in board. Say y is equal to phi x, lower limit phi x ft dt. Now, if you wish, you can differentiate it directly. In place of t, you put the upper limit into upper limit differentiation minus lower limit into lower limit differentiation. That is called Newton-Leibniz formula. Newton-Leibniz formula. Okay. For example, suppose you have got x2 x square sin t dt. Now, if I differentiate, if you don't know this formula, what will be your approach? First, you will integrate this, then you differentiate. First, you integrate, then you put the upper and lower limit, and then you differentiate. But here, you can use this directly. First, sin, in place of t, put upper limit into upper limit differentiation minus lower limit differentiation is 1. So, in a fractional second, instead of using integration, using Newton-Leibniz theorem, that type of integral where lower and upper limit are both also variable, you can manage. There is advanced version of Newton-Leibniz theorem. Okay, but today up to this stage will be enough, and we will do something, some more formulas, some shortcut trick, advanced two variable Newton-Leibniz theorem in next class. And if you have any doubt, or if you need more more explanation on it, you have to see VidyaNest class. VidyaNest app, you have to download. Okay, so till then, whatever is taught, hope you understood. Next day we'll discuss something more on it, on definite integral. Till then, goodbye. Thank you.